Type widening and type narrowing play a crucial role when working with variables in TypeScript. When a variable is declared using the let keyword and initialized with a value, TypeScript infers a collective type for that variable. This is because the variable can be updated with new values during its lifetime. In this example, we can turn Benny into Sophia. When we use the const keyword in TypeScript, the compiler infers a string literal type because we initialized a constant. This indicates that the value of the constant cannot be reassigned. This behavior is applicable to all primitive data types as they are inherently immutable. In the documentation of the Mozilla Developer Network, we can see a list of all primitive types, including null, undefined, Boolean, number, and more. These primitive types are passed by value when assigned or given as function arguments. Unlike object types, primitive types do not possess any methods. When necessary, JavaScript automatically coerces them into their corresponding object wrapper types, enabling temporary access to methods and properties. In contrast to the primitive types are the object types, sometimes also called complex types or reference types. In JavaScript, these are represented through objects, arrays, and functions. They are called reference types because variables of these types store references, memory addresses, that point to the actual value stored in memory. Reference types are mutable, allowing their values to be modified even when declared as constant. In our example, we can see that when a user is initialized with an object, TypeScript widens the type of the name property to a collective string instead of a string literal. This behavior occurs because objects are reference types and allow the name value to be changed. To prevent this from happening, TypeScript 3.4 introduced a new construct for narrowing values called Const Assertions. By using the asConst syntax, we can enforce immutability on the values of a reference type. This also narrows down the object shape by applying a string literal type and the read-only modifier to ensure the values cannot be modified in TypeScript. According to the MDN documentation, arrays are also considered regular objects and as such fall under the category of reference types in JavaScript. When assigning a constant to the first element of an array, TypeScript infers a collective number type. This is because it cannot guarantee the value's immutability since array elements can be modified. When using a const assertion, we can indicate to the compiler that the values in the array should be treated as immutable. This forbids reassignments and narrows the type from a collective number to a number literal. Throughout this tutorial series, we will primarily use the asConst syntax for defining const assertions. However, it's worth noting that there is an alternative syntax available, which involves using a tag to specify the assertion. Please be aware that const assertions are a feature exclusive to TypeScript and only enforce read-only behavior when accessed through TypeScript. As you can see in the TypeScript playground, the use of the asConst syntax does not generate any additional JavaScript code, meaning the array remains mutable when accessed with traditional JavaScript. To ensure that values of your object type are also non-writable in plain JavaScript, you can utilize the static object freeze method. When the useStrict pragma is used, it activates JavaScript's strict mode, which triggers an error when attempting to modify elements of a frozen object.